All right, welcome everybody. Let's continue our journey of probability. And here within chapter 4.3, we're going to talk about some multiplication rules and the conditional probability. So let's take a look at the first example. Let's say if a coin is tossed and then a die is rolled, what is the probability of getting a head when you flip the coin? So let's see if I get the head here. And yes, we get the head. All right, so what is the probability of getting the head on the coin and getting a 4 on the roll? Okay, let's just imagine that became a 4. How do you actually calculate this probability? So before we actually dive into the math, let's understand that. Notice that the flipping of the coin does not affect the probability outcome of rolling the die. Okay? So this is said to be an independent event. Two events are said to be independent events if the fact that A occurs does not affect the probability of B occurring. So notice that flipping the coin has no effect on rolling the die and vice versa. So we're going to say that these events are independent. Okay? Let's take a look at, and what I'd like you to do is please, copy this down into your notes, right? All right, so let's look at the next scenario here. Let's look at some examples. Rolling a die and receiving a 6, rolling a second die and receiving a 4. Notice that if I roll one die and I roll another die, every time you roll the die, the rolling of one die does not affect the roll of the other die. Okay? Let's take a look at another example. If you draw a card from the deck and getting a queen. So what's the probability of getting a queen if I just pick a card? It's 1 out of 52. But let's say if I put this card back and I say, oh, what's the probability of getting a second queen, right? Notice that when you put the card back into the deck, you still have 52 cards, okay? So, yeah. Now here, when two events are independent, the probability of both occurring is probability of A and B is equal to the probability of A times the probability of B. So when we look at this example over here, actually, let's take a look at this example over here. What I'd like you to do is this should be part of your lesson. Let's go through example 9 and 10 first. So what is the probability of a coin? If a coin is flipped and a die is rolled, find the probability of getting a head on the coin and a 4 on the die. So notice that we could use this multiplication rule over here. So if we have the probability of A and B, this is equal to the probability of A times the probability of B. So we have that keyword and over here. So notice, what is your A? Your A is getting a head on the coin. So notice, what is the probability? This is your A over here. And what is your B in this situation? It'll be getting the 4 on the die. So notice, what is the probability of A and B? All we need to do is, what's the probability of getting a head on the coin? This is just 1 over 2 times, what's the probability of getting a 4? It's 1 out of 6. So all we need to do is just multiply these two fractions, and we're just going to get 1 over 12, and that is the probability that you get a head on the flip, and a 4 on the roll. Okie dokie. Let's take a look at the next scenario. Here, a card is drawn from a deck and then replaced. So what this means is, from this sentence over here, that if I were to, let's say, pick a card, right, any card over here, what I'm going to do is, when I draw the second card, before I draw that second card, I'm going to put this card back into the deck. So notice that I still have 52 cards in the deck. So now it's saying find the probability of getting a queen and then an ace. So probability of queen and ace. So let's see. What is so this should be probability of queen times probability of ace. Sorry. Probability of ace. So notice, what's the probability of getting a queen from a deck of cards? It's 4 out of 52. And notice that, let's say if I pick up the queen, right? Let's say, oh, I get lucky, I get the queen, right? Now, what am I going to do? I'm going to put this queen back into the deck. So it's not like I have 51 cards. Now I still have 52. So notice that these are still independent events. Okay? So now this is 4 over 52, because there's still 52 cards in the deck. So 4 over 52 times 4 over 52, I don't know what that number is. What is 52 squared? Let me get my calculator. Let's see, 52 times 52 is, okay, so that's 2,704. And I guess we could just, reduce the fraction, and whatever that is, that's our solution. Okay? Let's take a look at the next scenario. Here, it's saying a card is drawn from a deck, and then it's not replaced back into the deck. And then the second card is drawn. So now here, notice that in this scenario, we have independent events. Okay, this is independent. Here, this is also independent. But here, we need to pause for this question for a quick second. So let's take a look at the next scenario here. When the outcome or occurrence of the first event affects the outcome or occurrence of the second event in such a way that the probability is changed, the events are said to be dependent. So for example, so let's say if I draw a card from a deck and then I don't replace it over here. Actually, let me zoom my camera angle a little bit out. Here, if I draw a card from a deck and I don't replace it, notice how many cards are in the deck. There are 51. Okay? So let's take a look at some other situation here. Okay, let's pick this one. Being a lifeguard and getting a suntan. Notice that if you're a lifeguard, most likely you're going to get a suntan. Okay? Or let's say having high grades and receiving a scholarship. Like, these two things are dependent on one another. Okay? Yeah. So let's take a look at this question here. Let's imagine the probability of drawing an ace, not putting it back into the deck, and then drawing a king. How would you find this probability? Okay, so what I'd like you to do is first copy this down into your notes. This idea of conditional probability. It will make sense soon. Okay, so just take a second and copy this down, and I'll read it. It's saying the event of drawing a king on the second draw, given that the ace was drawn first, is called a conditional probability. So the conditional probability of event B in relation to an event A is the probability that event B occurs after event A has already occurred. And that seems like a lot, and what I'd like you to do is this will feel better with some practice problems. So just be patient with this part, okay? And the notation for this is this means it's the probability of B occurs after A has already occurred, okay? And this notation over here does not mean you're dividing B divided by A. Okay, so what on earth am I talking about here? Let's actually go through this problem here. It's saying, imagine that the probability of drawing an ace and not putting it back into the deck and then drawing a king. Let's take a look at this question over here. So notice that, let's first do the first part. What's the probability of drawing an ace? Notice that drawing an ace is 4 out of 52. Now notice you're not putting the card back into the deck. So let's say if I randomly pick up an ace. Oh look, I randomly picked up an ace, right? So if I picked up an ace, right, and if I don't put it back into the deck, notice how many cards do I have here? We have 51 cards. But then what's the probability of drawing that king? Now it becomes 4 over 51 because there's one less card. And all we need to do is just multiply these two fractions over here, and that becomes our probability, which is going to be 16 over whatever this is. What is 52 times 51? 2,652, right? Okay. So yeah, And that's the idea here. And the real or the technical way of showing this probability, you say when two events are dependent, the probability of both occurring is probability of A and B. So it's the probability of A times the probability of B. Of B occurring. How do I read this? The probability that B occurs after A has already occurred. Okay, and that's this over here. So I promise you with some problems this will feel a lot better, but please take a second and copy this down. Okie dokie. So we're done with this part here. So we could also do this example here as well. It's saying a card is drawn from a deck and then it is not replaced back into the deck. And then the second card is drawn. Find the probability of getting a queen and then an ace. Okay, so it's very similar to the previous one. Pause the video and try and do it yourself. But notice that what's the probability of getting that queen? It's 4 out of 52. But now you're not replacing the card back into the deck. And then how many aces are there? It will be 4 over 51. Okay? And it was the same probability as before. Okie dokie. Let's move on to the final part of this lesson over here. And this also, I ask you to be patient for this one. So let's take a look over here. The conditional probability. Here, let me fix my camera angle. Sorry. Okay, that's better. The probability that, and take a second and please copy this down. The probability that the second event B occurs, given that the first event A has occurred, is the probability that B occurs after A has already occurred will be the probability of A and B over the probability of A. So what I want you to do is just copy this down for now and then ignore it. We're going to come back to it. Okay? Let's move on to the next part. And this lesson is pretty much almost done after this example. So let's take a look here. What I'd like you to do is take a second and copy this down, and we'll go over it together. And also copy these two questions down as well. This one and this one. 1 and 2. Okay. So let's take a look at this survey. It's saying a recent survey asked 100 people if they thought women in the armed forces should be permitted to participate in combat. Okay? So notice that how many males, so 32 males said yes, 18 males said no, 8 females said yes, 42 females said no. I just found some random question and these were the stats on it. So notice that how many males were there? There were, 32 plus 18, there were 50 males. There were 50 females. Notice that 40 out of the whole total said yes, and 60 out of the whole total said no. So notice that when you added 40 plus 60, you got 100. And when you added all the males and females, you did get 100 over here. Okay? So now let's try and look at this next question. What does it say? So now here, it's saying, let me have this over here on top. It's saying, let me fix the camera angle a little bit. Okay, much better. It's saying, find the probability that the respondent answered yes, given that the respondent was female. What I'd like you to do is trust your Jedi senses. Okay, try and find out what this is on your own without using. Just use your guts. And what I want you to do is try and find this on your own, what you think it is, and pause the video and really try to figure what do you think the answer is. Okay, and don't worry about any formulas before. Just try and do it on your own. So let's take a look here. Let's see. So how many females are there? So you know, it says, what is the probability that the respondent answered yes, given that the respondent was a female? So you know that the respondent was a female. How many females are there? There are 50 females. And how many of those 50 females answered yes? It was 8. So boom. It should be 8 over 50. Okay. Now, if you were like, okay, mister, or, whatever, just be patient with me. I pinky promise you this will feel better. Okay. Try and do the next question. Here, the respondent, so notice how did I do, let's kind of go back. How did I do this question? First, I looked at the females. First, I looked here. And then I looked here. Okay, so what I want you to do with that pattern, try and look at this. The respondent was a male, given that the respondent answered no. So try and do this one with this same format. I'm sorry, let me actually review this one again. So how did I do this? The respondent answered yes, given that the respondent was a female. So notice how many females are there? There are 50. You know that the respondent was a female, so there are 50 females. And how many of them answered yes? It was 8 of them. So that's the probability that the respondent answered yes, given that it was a female. Okay, so first we looked at the females, the number of females, and then how many actually said yes. Okay, from the females, right? Now let's take a look at this one. The person said no, the respondent said no, given it was a male. What I want you to do is try and use your Jedi or your gut instincts and try and figure this one out. So notice here it says, if you pause the video and now you want to see, here, so let's look at how many people actually said no. 60 people said no. Okay, so here we're going to have 60. And how many of the people who said no were male? It was 18. So we have 18 over 60. Okay, and that's it. But how can we use this little magic trick over here that I asked you to copy down and ignore before to actually go through this scenario over here? So let's take a look over here. The probability that B occurs after event A has already occurred. So here, let's look at this example over here. Notice that the probability that B occurs after A has already occurred. So notice that the person was already a female, and now we want to see how many of the females answered yes. So just watch this setup. Let this be the B and let this be the A. So what is the probability of yes given it was a female? Okay, so now let's just follow this. Notice that this is the this is the B, and this is the A. Okay, so we're just going to follow this format here. This is the B, and this is the A. So this is equal to the probability of, well, now what's our A? Female, and what is the B? It's yes, over the probability of female, right? Now let's see why this magic will work. Okay, so now here and please be patient. It will click. I just need time. So let's take a look over here. What is the probability of female and yes? So let me fix the camera angle a little bit, and let's take a look at this. Probability of female and yes. How many females? Let me fix the camera angle here. This is better. Okay, looking at this over here. Probability of female and yes. How many females did say yes? It is 8 over 100. Okay, notice that probability of female and yes. There are 8 females who said yes out of the 100 people. Okay, but what's the probability of getting a female? Notice that there are 50 out of 100 females. So now here, how can we actually finish up the math for this? If I have 8 over 100 divided by 50 over 100, now here, how do we actually figure this out? Let's actually divide this fraction, right? What is 8 over 100 divided by 50 over 100? And notice, how do we divide fractions? We need to do keep, change, flip. So here we're going to keep the 8 over 100. We're going to change this division to multiplication, and then we're going to flip the 50 over 100 to 100 over 50. Okay? And notice what happens here when you continue. Notice that these hundreds cancel, and you just have 8 over 50. And that's what we wanted before. I mean, that's what we had before, was that 8 over 50. And that 8 over 50, we kind of just used our guts or our instincts. Or well, I did, and you tried to follow. And if you were able to follow, great. And if you weren't, it's not the end of the world. But here, we could actually use this setup to actually find the probability. And yeah, and this conditional probability will work. It's just 8 over 50, right? What I'd like you to do is try and do the next, and here we have to simplify it. So what is this? 4 over 25. Okay. Try and do the next question on your own using the setup of probability of B given that A has already occurred. It's equal to the probability of A and B over the probability of A. Okay? And notice we should get 18 over 60 when we actually do this. So here, if you pause the video and you try to do this on your own to get 18 over 60, we have the probability of male and no. But then this is equal to the probability of no and male over probability of no. So notice how many males actually said no were 18 over 100 divided by, notice how many, my bad, let me fix this. How many males, how many people who said no were also male? It was 18 out of the 100 people. And notice how many people said no. It was 60 over 100. So now we just have, and it's the same idea before, these hundreds just cancel and you have 18 over 60. But if you simplify it, it's 9 over 30, which is 3 over 10. Okay. Okie dokie. I hope this was okay. I know this might not be the best situation to learn conditional probability, but what we're going to do is for the homework section, let me actually get the paper. Yeah. For the next part of the section, what I'll do is I'll ask you 3 questions. What I want you to do is, this should also be attached to the email, right? Try and do questions 1, 2, and 3 and question 4 by yourself. And what we're gonna do is I'll make a separate video and I'll go over these questions with you. But try your very best to do questions 1, 2, 3, and 4 on your own. Okay, I'll see you in the next video.